Hello friends, today we are going to see two other forms of the straight lines. We had already seen three forms of straight lines. One is slope-intercept form, second one is point-slope form, and third one is two-point form. Apart from these three forms, we still have two more forms of straight lines left, of which the fourth one is intercept form of the line. Intercept form of the line. Now, the equation of the line which cuts off intercepts A and B respectively on x-axis and y-axis is of the form x upon A plus y upon B is equal to 1. Let me repeat one more time and write it down. The equation of a line which cuts off intercepts A and B respectively on x-axis and y-axis is x upon A plus y upon B. So now we are going to derive this intercept form of the line. For that, let me first draw both axes. So this is my y-axis, this is the x-axis. This is x and y-axis. Let's say this is the line L, which makes x-intercept and y-intercept as A and B. X-intercept is A, that means this point of intersection. Let me have some other color for the intersection point. So these are the 2 points of intersection of the lines on x-axis and y-axis respectively. So when I say x-intercept is A, that means this distance from the origin to point A, where A is the point of intersection of the line with x-axis, is small a. And let's say point B is the point of intersection of the line with my y-axis. Then this length becomes small b. Now I can see that my point A and point B are on x-axis and y-axis respectively. And the distance of point A from y-axis is small a, and distance of point B on y-axis from x-axis is b. So the coordinates of A becomes A, 0 and that of B becomes 0, B. Now I see that my line L passes through two coordinates A of A, 0 and B of 0, B. So by 2-point form of the line, I can say that the equation of the line was y minus y1 is equal to y2 minus y1 upon x2 minus x1 of x minus x1. So this was the 2-point form of our line. I'll substitute the two forms having x1 and y1 coordinates as a0 and x2 and y2 coordinate as 0b. So I'll substitute x1 as a, y1 as 0, x2 as 0 and y2 as b. So I'll get y minus 0 is equal to b minus 0 upon 0 minus a of x minus a. So I'll get y is equal to b upon minus a of x minus a. To further evaluate and cross multiply, I'll get minus a of y is equal to, I'll open the bracket over here on the right hand side, I'll get b x minus of ab. I'm sorry, bx, yes, minus of ab. Now I'll brought a minus y to the right hand side and ab to the left hand side. I'll get ab is equal to bx plus ay. I can write this equation like bx plus ay is equal to ab. Now dividing both the side by ab, I'll get bx upon ab plus ay upon ab is equal to 1. So b and b got cancelled out, a and a got cancelled out, so I got x upon a plus y upon b is equal to 1. So this was the equation of the line which we were about to derive. The equation of the line which makes x-intercept as a and y-intercept as b. That means it intersects the x-axis at a and y-axis at b. So this is our intercept form of the line. Coming to the last form of the line, which is a fifth form, and that is called as normal form of the line or perpendicular form of a line. So the statement of the same goes like this: the equation of the line upon which the length of the perpendicular from the origin is, let's say, small p, and this perpendicular makes an angle alpha with the positive direction of x-axis is x cos alpha plus y sin alpha is equal to small p. So the equation of the line upon which the length of the perpendicular from the origin is p, and this perpendicular makes an angle alpha with positive direction of x-axis is x cos alpha plus y sin alpha is equal to p. So we are going to derive another form of the line, which is x cos alpha plus y sin alpha is equal to p. For that, let me draw my axis first. Let's say this is my y-axis and this is my x-axis. Let's say this is my line L, and a perpendicular from the origin, perpendicular from the origin is drawn to the line. The length of this perpendicular is small p, and this perpendicular makes an angle alpha with the positive direction of x-axis. So this perpendicular makes an angle, this angle as. Now let us point this as the origin. Let the point of intersection of the perpendicular to the line, this one, be capital P. Let my line intersect at x-axis at A and y-axis at point B. Now OP, I can say that OP is equal to small p, that is equal to perpendicular drawn from origin to line AB. Now I'll drop a perpendicular from point P on x-axis and y-axis. Let's say perpendicular which I drop from point P on x-axis intersect the x-axis at point Q, and the perpendicular I drop from point P on y-axis intersect the y-axis at point S. So I can say that PQ is perpendicular to OA and PS is perpendicular to OB. Now in triangle POQ, that is this triangle POQ. In this triangle I can say that I'll apply the trigonometric cosine rule, which says cos alpha is equal to base upon hypotenuse. My base over here is OQ and my hypotenuse in triangle OPQ is OP, since this angle is 90 degree. So I can write cos of alpha is equal to OQ upon OP. I'll substitute the value of OP as P. So I'll get cos of alpha is equal to OQ upon small p. Further which I cross multiply and I got OQ is equal to P of cos alpha. I name this equation as number 1. OQ is equal to P of cos alpha. Similarly, I can say that sine of alpha is equal to PQ upon OP, but my PQ is equal to my OS, so I can write that OS upon OP can be written as sine alpha. So OS upon small p is equal to sine alpha. That means OS is equal to small p sine alpha. I name this equation as equation number 2. Now I can see that my OS and OQ represents the coordinate of my point P, since x coordinate represents the distance from y axis to the point and y coordinates represent the distance from x axis to the point. So OQ represents my x coordinate, that is P cos alpha, and OS, that is P sin alpha, represents my y coordinate of point P. Hence I can say that OQ and OS are coordinates of point P. Further which I can say that therefore P cos alpha comma P sin alpha are the coordinates of point P. Coordinates of point P. Now I know that my AB is perpendicular to OP and OP makes an angle alpha with the positive direction of x-axis. Hence the slope of AB into slope of OP is equal to -1, since both are perpendicular to each other. Hence the product of the slope of AB and OP gives me -1 as the result. Therefore I can say that slope of AB is equal to -1 upon slope of OP. But slope of OP can be written as tan alpha, where OP makes an angle alpha with the positive direction of x-axis. So its slopes become tan alpha, where slope of OP is equal to tan alpha. Now I see that my equation of the line passes through point P and has slope as -1 upon tan alpha. So over here I can write that equation of line passing through point P, small p cos alpha and small p sin alpha, and having slope -1 upon tan alpha is y minus y1 is equal to m of x minus x1. I can use the Points law form over here. So x1, y1 are p cos alpha, p sin alpha, and m is minus 1 upon tan alpha. So I'll substitute the value of the same in this equation. I'll get y minus p sin alpha upon minus 1 upon tan alpha of x minus p cos alpha. I can further write this as p sin alpha is equal to minus of cot alpha minus p cos alpha. That is equal to p sin alpha is equal to minus cot alpha. I can write it as minus cos alpha upon sin alpha of p cos alpha. I cross multiply the same, so I'll get y sin alpha minus p sin square alpha. Sin will get multiplied with this sign, and I'll get sin square alpha is equal to minus of x cos alpha, minus cos alpha into minus p cos alpha gives me p cos square alpha. So I'll take this minus x cos alpha on the left hand side, and I'll take minus p sin square alpha on the right hand side. My equation becomes x cos alpha plus y sin alpha is equal to p cos square alpha plus p sin square alpha. So my equation becomes x cos alpha plus y of sin alpha is equal to, I'll take p common from both the terms, and I got p of x cos square alpha plus sin square alpha. I know that cos square alpha plus sin square alpha for any degree alpha gives me 1 as the answer. So I get p into 1 over here. X cos alpha plus y sin alpha is equal to p into 1. Finally, my equation becomes x cos alpha plus y sin alpha is equal to p. So this is the equation of the line upon which the length of the perpendicular from the origin is small p, and this perpendicular makes angle alpha with the positive direction of x-axis.